For a scene like this, we'll understand it in ways like this. So you can see some tags appearing here. These are all coming from our API. And you can see interesting high-level objects like mountain and snow and sky, but also these descriptive words like reflection and travel, scenic. We can understand all these different things by taking in just the pixels and processing it with a neural network, specifically trained to recognize these types of concepts. And just a quick disclaimer, there's going to be some potentially offensive content in this. It's going to be nudity related, but it's actually not like explicit images, it's visualizations of nudity. So if you're offended by that, I will let you know right before that happens, but if you don't want to watch the rest, then that's okay. So we're based in New York. So I started the company about 2.5 years ago now, and right after incorporating, ended up winning ImageNet 2013. So right off the start, we had the world's best image recognition and have been improving it ever since. Improving it in different dimensions, whether it's the number of concepts that we can recognize. We now understand over 11,000. The amount of data we're training on, tens of millions of images. And really the types of concepts have been iterated on over and over again for the last 2.5 years to hone in on exactly what our customers and developers want. It's basically the idea that you can take your camera out of your pocket and take a picture, and we'll tell you meaningful stuff about it. And we're also backed by some really exciting venture capitalist firms. Union Square Ventures is based in New York. Google Ventures, you might have heard of, and NVIDIA as well, their venture arm. So we set out to bring this technology, neural networks, deep learning, to developers and enterprises through a simple-to-use API. And so when you take an image like this, we'll return tags like this. You get both the tag, but also the probability score out of the neural network. And I'll show you what that looks like in a second. So we build this platform that gets smarter and smarter over time and grows in the number of tags over time. So off the start, we started with around 2,000 tags. Now we're 11,000 plus. And we add them in a variety of ways, from hearing what customers care about to identifying things that are not going so well in images we see, and things that should be added over time, some obvious choices. And so with these tags and the understanding of them, we can take in any image and associate those tags. And that makes it really simple for enterprises to understand their content that is exploding every single day in terms of number of images and video being used in their businesses. And previously they couldn't actually understand what was happening in that content. And now we can help them do that through our API. So it's very simple to use, just 3 lines of code, and you can understand content. And they use it for a variety of reasons. It's either to increase revenue, or maybe it's to improve efficiency, or just avoid kind of technical overhead and debt. So in terms of increasing revenue, it powers applications like this. You can search by tag, you can find visually similar content, and you can curate the content. This unknown blob of data that enterprises used to have can now be understood. Or improve efficiency. A lot of companies have been doing this manually before, and now with a real-time response you can enable new types of applications very quickly. You can also moderate content. Maybe it's unwanted content, not just the wanted content, so you want to remove it from your site. And this was traditionally a whole moderation queue and several hours of delay between images being uploaded and being moderated or filtered out. And you can also power really high-level analytics with this type of technology, so that you can maybe look at social media streams and understand what your brand is, how your brand is being talked about, for example. And avoid technical debt. You don't need a data science team or research team in every single company in order to have deep learning in every single company. And so we bring the latest in machine learning from great conferences like this into enterprises so that they can leverage it. And they don't have to build their own infrastructure. It's all hosted in our cloud, so they don't have that infrastructure cost or maintenance cost. And it's scalable. We scale with whatever volume you have. And here's kind of a handful of the customers that use us every single day. A wide variety, different verticals, different use cases are all being powered by Clarifai. So I'll show you what it looks like. So off the start, right after creating the company, the very first thing that was built was a very simple to use demo so that other people who are non-developers could actually see what this technology means for their business. So you can just drag an image onto the screen and it's uploaded and automatically understood. So the image on the left here, just the pixels were analyzed, and here are the top tags that our system predicts. So this is out of the 11,000 categories we understand. And you can see objects like lake are recognized, but these descriptive ones are really interesting, like reflection, or there's no person in this scene, or it's placid. So you can get this whole other dimension of understanding of your content, make that searchable. And when we talk to customers, this is a really exciting dimension because it's kind of an emotional connection or just more descriptive connection, not just the objects that are present, which is a little bit cold in nature. So it's really exciting to be able to recognize these things automatically. So after launching images, which was our initial approach in the API, we also launched video. So I just pasted in a MP4 file here. This is at some public location, and it's being downloaded right now by our servers. And it's running these classifiers throughout the entire video. So what we return is a whole time series of information. So all these 11,000 things that we can understand are being looked for throughout the video and summarized at 1 second intervals of what it's seen. And so what we're showing here are 5 different lines that represent 5 different concepts that are shown here: no person, landscape, outdoor, sky, and travel. So if I'm looking maybe for an object which is more concrete, like mountain, the height of the line here is how confident it thinks that a mountain appears within the video. And so if you jump to a scene like this, it's very confident there's a mountain here, so I can see in my video that there's a mountain there. Now, all these concepts, we also made sure that are recognized independently. And this was a little bit of a research effort in order to change the loss function that makes it possible to train this at scale with 11,000 plus concepts. And so the result is we can see snow and mountain are present here, and water is unlikely, so we get a scene that looks like that. Whereas here, water is also likely, along with snow and mountains. So we get that lake in front of the snowy mountains. So this allows you to search for any of these concepts independent of one another and slice and dice into your videos, which powers a whole new set of applications around video. And you can see here on the scroll bar, this was a 3.5 minute video that we processed in about 7 seconds or so. So much faster than real time, we can understand your content. Another exciting research effort was to not just support English, but we want to support all the major languages across the globe. So here is a list of our currently supported languages. There's over 20 of them. So I can grab anything like Chinese here and throw in an image. And there's a quick CAPTCHA to prevent crawlers. And the image is uploaded and automatically understood in Chinese. Or maybe I can throw in Italian. Oops. That's a CAPTCHA issue. So here you can see I think I chose Spanish, and here you can see Chinese. So this was an interesting problem because we couldn't just use a service to do this. We couldn't call a translation API or anything like that because typically those translation APIs are doing one word to one word. And the problem with that is there's words in English and in other languages that have multiple meanings. So what we've developed, and for example, words like this. So the word fall on this image on the left could mean the season of the year, or it could mean that the leaves are falling off the trees. So both of them are actually present in the same image, and they have completely different meanings. And so we had this issue where all of our data had been annotated with fall, a single tag, but we knew that there was actually different meanings of the same kind of English phrase in there that we had to disambiguate. The other problem is that these multiple meanings might happen in completely different images, like crane. It's possible, but it's unlikely you'll have the device that lifts things and the species of bird in the same image. But we have to handle both those cases where they're in the same image or in separate images. And so to tackle this, we set out to build a whole natural language processing toolkit that essentially looked at other knowledge graphs in the world, Wikipedia, WordNet, Freebase, DBpedia, all the common ones, and extracted commonalities between them and compared them to what our visual system could understand in the world and how it could see that I see the word crane, but I see a lot of differences between the bird and the machine. We might even see that we tag machine or we might tag bird in these two different examples. And so we can leverage all those tools together to build our own knowledge graph. And that's what we've done inside of Clarifai. We have a new knowledge graph that has each node has been disambiguated in the meanings. It has a clear definition, it has synonyms, and then it has all the language translations into over 20 different languages. And that was a huge effort we did in the fall, and now it's public for you as you sign up for the API. And all you need is 3 lines of code to basically import a client, authenticate, and then choose whatever language you want to understand your content in. And that applies to both image and video. So we also have been working on a few other models. One of them is called Not Safe for Work, which I'll get to in 1 second. There's also one we built for food, which was a common use case. So we can grab an image like this and throw it into the home page. So this should call the food model. And we actually call it the food items model because the goal of this was to, the previous speaker actually showed an image with food in it and asked the question how many calories were in it. That's exactly the type of application our developers want to build with our technology. And so we built a food items model that can break it down into the individual ingredients, ideally lettuce, tomato, bread, meat, sandwich, ketchup, bun. It sees a French fries on the side, cheese, and the best part I loved about this example was it saw chicken. It didn't go to the default association once it saw that it was a burger and, say, beef. So it can actually tell these ingredients apart independent from one another. So really powerful models. And what we call this here is a domain model. So we have food as one domain model. We have NSFW, which I'll show you in a second. But we also have a few other models catering to different domains. Trivago is one of our awesome partners who we worked with on a travel model. So they had a bunch of data in the hotel space where their hotels upload images because they want to showcase their hotels, and they want to let users be able, or Trivago wants to let users be able to search over those images to find things like ocean view or pool or the spa or the bedroom, so that when you're finding your next vacation, you can say, you know, the best pool is in Jamaica, and it'll go and find those images for you and makes it easier for you to find that vacation destination. So that's powered by what we call our travel model, and that's available now in our developer hub. So if you look on the left here, we have a whole set of models. So it's not one size fits all, which the general model provides, which is the use case of social media, consumer photo organization, analytics, those kind of where you don't know what type of images you're going to expect. When you do know, you can use one of our domain-specific models. And we have one for travel, as I mentioned, food, like I showed, but also weddings. So here, instead of saying flowers, it might go into the details of telling you the type of flower. Or instead of saying man and woman, it'll tell you bride and groom. So it'll automatically go that next level for you because it knows that you're expecting to throw in wedding photos. And then we have a pornography model. So NSFW, this is looking for porn, and it has a single category where 1.0 is explicit pornography, 0.0 is super safe content, and then some intermediate value, maybe 0.8, might be bikinis or lingerie or something like that, some intermediate thing. So it's up to you as a developer to decide how you want to treat that content on your end, and maybe blacklist it from your site or put it in a different section, or it's up to you. So this was an interesting model that we built, and this was not driven by customer need. It was really how we thought about the world. We knew this was a problem that customers had, and they weren't coming to us for it, but we knew once we built it, they would. And it's because we built simple demos, and our data science team made this. I don't always stream Twitter data into my demos, but when I do, it's full of porn. And this is definitely true. Twitter, any of the social media sites are full of pornography content. Anytime there's an upload button on a site, it has that scenario. So we built this internal demo, was called Clarifai, and we did it to kind of analyze how our models apply to social media. And we just used the Twitter 1% fire hose, ran it through one of our general models, indexed it into a SQL database, and now, and when we looked after querying in that database what the tags looked like, you would search for anything, people, and it would just be about 30% pornography or something like that. And so now, with this model, we can apply the model, write it back to the database, and filter it out based on the probabilities we decide on, and then that makes a clean tweetify. And so the progression of this field has gone a long way. So this is a paper out of 1996 from Chris Bregler and some others, and they had a very simple approach to the problem where it would combine color and texture properties and obtain a mask of skin regions because they tried to hard code, how to look for pornography. And they basically had this grouping function that could group these regions together and then say that's pornography or not. And it looked something like this. They had some model of how these different regions would kind of relate to each other. And once they found regions that kind of aligned, they would say that must be a person and they must be naked because of the color, and so flag that. And you can see this is one of the figures out of their paper, some of the false positives. This was a loaf of bread that kind of looks like a person laying down maybe. These were completely different, separate objects, but they also fit the rigid structure they were looking for. And then this one, it's kind of hard to see. I'm not sure what happened there, but it looks like it found a whole pile of people or something. So that's kind of the previous approach, and that's back in 1996, but there's been many other results since then. And of course, we're applying neural networks to the problem. So take them in, run convolutions, pooling over and over again until you get some category as output. In this case, it's a single output, not a set of objects. And so this is what the end results, I think this was before the final result, it's version 0.1. So it looked like this. So really good results up in the top right. So the data we used here was actually collected from the web, and that's something we take a lot of pride in at Clarifai, is being able to do data collection in a clever way. We actually, all of our production models have never been labeled by a worker that we pay. They're all automated. The data collection is all automated. So this was automated from a collection from the web and also from a few of our customers who were having this problem with pornography. They had some nicely labeled content as they tried to tackle it manually themselves. And so after a lot of iterations, the challenge here was the safe stuff is really easy to recognize. The explicit pornography is really easy to recognize. It's the bikini shots and the lingerie that are difficult. So we had to kind of mine for good examples over and over again using a previously trained model to find those tough borderline cases, and then refactor that in and re-weight the distribution of data and then retrain. And so we did this in a loop over and over again, and eventually would push the accuracy up into the corner. And so one of our data scientists made a really cool blog post. I don't know if any of you have seen it, but it was based on some previous work that Rob Fergus and I did at NYU back in the day in 2014. And the work was to understand what these models are actually learning. And so once we trained a pornography model, we wanted to know what it was learning and what it was thinking about images. And so the approach is based on networks called deconvolutional networks. And so everybody here probably knows what a convolutional network is. It takes in the image, applies convolutions, maybe nonlinearities, maybe some pooling, and then that repeats. That's the feature maps that are output from that module, and you stack a bunch of those over and over. So deconvolutional networks are top-down. And this was work with Rob Fergus and Graham Taylor as well, a previous speaker today, that the goal here was to do unsupervised learning. So no labels, just take in the image, and instead of going feed forward, we're going top down. So we want to infer or guess the feature maps that most optimally reconstruct the input image while using the fewest activations in those feature maps. We wanted them to be sparse. And so it had a penalty for reconstruction and a penalty for sparsity. And it would undo all these operations, unpooling, apply nonlinearity, and do the convolutions. So in order to visualize these convolutional networks, we don't do that iteration. We're not trying to optimize for the feature maps. We essentially take a convolutional network and run it up to get the feature maps, and then we use a deconvolutional network to reconstruct them, reconstruct a visualization of the image. And that visualization gives us information about what's been extracted by the network. So there was one important trick that I actually see a lot now being used in some unsupervised methods where they're trying to, or segmentation methods where they're trying to get back up to the pixel space. The problem with going through a feed-forward pooling is you collapse the spatial extent. So a typical pooling region looks like this. You might be doing a 2x2 pooling, and that operation will take the maximum elements. But to make this reversible, we also record where those maxes came from. So for example, this white block here, so white might be positive and black might be negative. In this scenario, we are taking the strongest absolute value. And so we record that value, but we also say that it came from the top right element in that pooling region. And that lets us unpool. When we want to reconstruct and visualize these images, we have to do this unpooling. And that expands the size back from 2x2 up to 4x4. And the unpooling takes an element from above as we're reconstructing it through multiple layers, and it places it in that location where there was a max. So that preserves these really sharp edges and the meaningful information that went through the network on the way up. And that gives us a reconstruction. And so the process looks a little bit like this. On the right-hand side, we're going through multiple layers of feature maps and pooling. And when we do the pooling, we record those switches because we're going to keep going in the forward pass with the convolutional network and then reconstruct back down and have to do this unpooling. So we leverage that location information to unpool. And so this is what these models typically look like. So this is some results from that 2014 paper. This model was trained on ImageNet. And the first layer learns colored edges, different orientations, different frequencies, and different colored edges and blobs. So that's pretty simple. You can look at the weights of any ConvNet and see that. But this approach let us look into what the second layer was learning as well. So here, there was about 256 features in the second layer. This is visualizing the strongest activation for each of those 256 features. And you can see things like right in the middle here is a corner. So it's kind of composing these first level features. You can see circles here. So that's a really complex composition of multiple first level features, parallel lines, different colored lines, etc. are all kind of represented by the second layer of the network. By the third layer, this has gone through a couple pooling layers, so now it sees a much bigger receptive field. And you can see that it's starting to learn parts of objects, like a dog's face over here, or a eyeball over here, or a baby's face on the far left, or even just grading patterns, might be a fence or something like that. So it's extracting these patterns and being able to recognize them all by the third layer. Fourth layer, I'll skip over. Fifth layer, fourth and fifth are pretty similar because there's no pooling in between. So the receptive fields are similar size. By the fifth layer, it's getting closer and closer to having to output what object it thinks is in the image. This was a, I think, 8-layer network, so almost there. And therefore, it had to start recognizing common things like faces, or there's a husky over here. This feature was basically tuned to recognize specifically huskies. There was keyboard up at the top here. This one was only keyboards, and might be from a remote control or your laptop. It could recognize all those different types. So this is all happening in these intermediate layers automatically when we're training convolutional networks. And so the final results in the paper look something like this. There was another experiment that we did where we occluded parts of the image, and you can't really see it too much detail here, but we basically took this block and blocked out some pixels of the image, ran the convolutional network up, and then looked at how the probability changed when we did that as we slid this block to occlude different parts of the image, or how some fifth layer activations changed. And you could see it was really tuned, meaning the convolutional nets are really localized to specific regions. And when this colored plot on the right is showing how the categories actually swap as you keep occluding different objects. So we took these same approaches and applied it to a few famous nude images and some data sets that we collected. So this is a very famous image, and you can read about Lena on Wikipedia. Basically, the image we always see and use in computer vision textbooks and experiments is this part, but this was actually a Playboy model, and beneath the crop, she was actually nude. So in the next few slides, you might see some nude content, by the way. So close your eyes if you want. So here, we tried the occlusion experiment using our not safe for work model. So we took a block and ran it over the image, the full-size image, that would set the values to 0, basically, 0 mean. The image was 0 mean, so we set them to 0. And so the result here is showing the probability of the not safe for work portion after we slid the block over every possible region. And you can see this gives you an idea of where the model is looking when it's trying to classify if it's not safe for work. And this was at one of the last convolution layers. So some of the features in those convolution layers are looking for different things. So one of them is kind of looking for the torso. Is the torso nude? Does it have skin tone? Or does it have exposed chest and stuff like that? Whereas another feature might be looking at the backside. So these things have learned automatically to recognize these different parts of a person that might be considered nude, even though the final classification comes down to a single result. So that was kind of an interesting experiment that it was decomposing like this. And then we looked at visualizing and applying these deconvolutions to see what kind of focus on that final classification was happening in the original pixel space. So you can see some different pictures of her. This was, like the previous experiment showed, the same image. It was looking at her whole chest and her backside. When it's just a face, it typically looks at the lips for some reason. It chose to do that, and you can see it's focusing on the shoulder here a bit. And then you can see it's focused on her chest when that's exposed. And so we took this and applied it to kind of the safer content and see what it does. Like I said, when everything's covered up, it looks at the face. That seems to be the only thing it cares about, and it sees the lips. And then when it's like a bikini shot, it sees the belly button. It seems to concentrate on that. It actually sees her chest a little bit, focuses on that. So the next slide might be a little bit offensive, but we took this and ran it over really explicit pornography and saw what it was looking at in those images. So, and that tells us what it focused on when it's really looking at the explicit stuff. And you get exactly what you expect. Basically, the genitals automatically are kind of focused on, and this is kind of the explicit pornography, so you see close-ups and stuff like that. So it was kind of an interesting experiment to run through these convolutions, apply to a real-world problem, and then see kind of after the fact what they're actually focused on. And we compared it to some of the kind of ones that have exploded on social media to see if we handle these cases too. So this one was an image that got flagged by Facebook's system, whether it was a human or automated system, I'm not sure. This was a few years ago. And you can see why it would have been flagged. That's actually her elbows that she's holding up, and our model thinks it's safe, so that's good. This one, you can see why a simpler approach might think that is a chest, but we think it's safe, and we're 97% confident. You can see this one, why it might be confusing. This one was a little bit easier than the other one. This is 99.9% confident it's safe. And then this one, so we just had to try it on a cat. And we're 99.9999, so that one's good. It's really tuned for human pornography. So that's the kind of research we do. We work on problems that we know our customers care about, and we have this core model, the general model. It's a very broad lens. When you take out your phone, take a picture, we want to help you understand that. Then we have these more specific domain models where they're solving real problems within a vertical: travel, wedding, food, pornography. And then we've even gone another level with some customers. So the core model might say this is a picture of a drink. The domain model might say it's coffee. But a specific model might say it's Starbucks. It can actually understand these really specific things that our customers are looking for. And this is the reason a lot of our enterprise customers decide to work with us. It's incredibly flexible. We make it as simple as possible to use, and we support them through the process. We're actually on the calls with them to solve their problem. And we can work on any of the platforms out there: Google's, Amazon's, Microsoft's, and we have a really active community, and we make it affordable to get deep learning into your system. And so I'll show you a few of these use cases. Style Me Pretty is in the wedding space. Their problem is their users upload entire wedding albums, and there are thousands or 2,000 of shots, and they want to make that searchable so that people can find these content when they're, planning their next wedding. And so this was done manually previously, and now we're letting them get an order of magnitude more content onto their site by automating it. And this was using the wedding model, about 400 or 500 different categories specific for the wedding space. And so the process looked like this, where an image would come in as the users upload their wedding album, and they would send those images to us, classify them, and we would give the results back to Style Me Pretty in real time, and they would just verify them with a human queue. So instead of removing the humans completely, they still leverage their moderation queue, but now they're doing 10 times the amount of work. So they have that high quality bar, but orders of magnitude more content. Trivago in the travel space, this is using the travel model, and has anybody used Trivago? I've used it multiple times. It's really great for booking your hotels, and they have a huge set of hotels all over the globe with a lot of images on each, so that you can actually look and see what you're booking before you do it. And now we can recognize, I think, about 200 categories specific to hotels, and their process is not end users uploading, but it's actually the hotels themselves. They pay professional photographers to make their hotels look incredible, and those images get sent to Clarifai, run them through the travel model, and then they are tagged and indexed on Trivago's side so that the next time you're booking a hotel, you can find that content automatically. Some different ones, Curate. This is a social media analytics company where they're trying to go through social media streams and find out how a brand is being conveyed. And so they have huge volumes of content and they need a really broad model, so they're using the general model. And they can see things that aren't present in hashtags or captions now that they're using us. And so the entire stream of social media flows through our APIs, and we tell them what's in it. That augments all the other data they have, maybe the person, the hashtags, the captions, all that other information. And then they can provide that back to their brands in analytics dashboards. So it's very simple to digest all the information. And then we even work in the medical space. So here we're looking for really exciting new applications in medicine, not necessarily the the big MRI machines that are $1 million and take up the size of the room. We're really excited by these new devices. So this is a company called Inside over in France, and they have a device that goes on the back of your iPhone or Android, and it records image and video inside your ear, nose, and mouth. And so doctors are using it today in the hospital and diagnosing patients with it. They built an app in there so that it's very simple to catalog all this information. And they gave us a dump of data from the doctor's responses, both image and video content, and they were looking for 10 different diseases, so we could train a neural net on that data. And now they're actually using it in hospitals with 99% accuracy. So that's another way we work with customers. It's not just we collect the data ourselves. We can actually work with them who are experts in their field. They collect the data, they give it to us, we train a model, and then we turn that around in our API. And so that's available with just a flag in the API, which model you want to use. And here's some of the feedback from customers, which I love to see. So they've claimed that it's ready to go in just a few seconds, no kidding, and it's always felt like the fastest response from all the APIs. So this is a blog post from somebody recently who tried out Google, Microsoft, IBM, and Clarifai together. So that was an exciting response from him. Stanley Pretty, CTO, says it's the most accurate out-of-the-box solution on the market. So we're actually solving these really fine-grained classifications. And then the medical company, Clarifai, differentiates itself by providing image recognition tools and solutions that businesses can use right now, not in 10 years. And that was our goal setting out. We knew this technology was ready, and we wanted to get it into everybody's hands. And that means getting into all of our hands. We all have this problem, not just enterprises, but everybody has a phone today, everybody in this room, and we use it as our primary camera. And so we wanted to organize that content as well. And so we built Forever, because our overall mission at Clarifai is to understand every image and video to improve life. And I'll show you what Forever looks like. So these are my photos, and they're now organized by the most recent, by people, places, things, and times. And you can even favorite stuff. So if I go into people, we've built something here from scratch to understand people's faces. And here I've already taught it my friends and family by going through this process. So off the start, it doesn't know anybody's name, but it knows that people look the same. So these 24 shots are one girl, it thinks. These 17 are one guy, 15 are another girl. And when I click on her, it actually pulls up a few kind of smaller clusters, and then I can add her name. And what happens when I hit save is it actually trains a neural net on the phone so that whenever I take a picture of that girl again, it'll automatically tag her. So we wanted to bring this whole new level of personalization and real-time machine learning into Forever. Places are just leveraging the geolocation, so now you can search over any possible combination. And things, this is leveraging our general model, which I said is really nice for personal photos. You can get all those sunset shots, and everything's searchable, so I can go and find them in Jamaica or something like that, maybe in 2014. So I can get exactly what I'm looking for. And browsing is really fun through these categories because you see, that's my wife, called her an actress. There's some funny ones like that. there's ones that are really high level. So togetherness is when people are, hugging, or a mother's with a child, people kissing, or a group of people. So it can understand all these different meanings of the same word and recognize them automatically. But when we set out, we wanted to really make this AI personal. And so we built in the ability to teach it anything in the world, not just the 11,000 concepts that we understand. So I taught it what a whiteboard is. So now whenever I take a picture in our office or anywhere of a whiteboard, it'll automatically recognize whiteboard and tag it. So I can search and find my whiteboard shots. And I can get specific too, like the name of my dog, or different, the Toronto Raptors or something like that, or this was a robot I built in engineering, and my wife called it Gus. So now I can make it meaningful to me. So the way you teach it is something like this. I'm just going to make a random name, but I'm going to teach it my dog. And it says add some photos of this thing. And so I'm going to search for dog. And I see him. And so I'm just going to start clicking on him. And instantly it says I've learned something. There's new suggestions below. And I keep clicking and get smarter. But you can see it's actually already learned in real time what he looks like. So what we did as you were looking around in the UI and clicking was actually training a neural net in the background and processing all of the images on the phone. So I have about 18,000 photos on my phone, and it ran through all of them in real time after it trained the neural net and ranked them all off the screen. And so it finds the photos automatically, and I didn't need 10 million images. I didn't need 6 weeks on a GPU. I only needed 5 images, and it's super accurate. So this is the type of research that we focused on at Clarifai, both on the speed, the minimal amount of data, but also the user interface, which is incredibly important for building a high-quality product that people are actually going to use and interact with. And finally, we built some AI into stories as well. So these are automatically generated stories, and you can see what I've been doing in the last few days. So my hand got kind of cut up. It wasn't looking so good. So this was the other day. I fell jogging, and you can see here my phone was smashed. So I got it fixed so I can do the demo. Woohoo! And then I got some beer because I was depressed. So my wife hadn't seen this, so I'm just going to hit send, and it sees that my wife probably wants to see it. It was the highest recommended person, and I fired it off. So it actually learns who I share with, and depending on the content, we'll pick a different person. So we're actually kind of trying to make it very simple and fast for you to share interesting stories with the people you care about most. And that's all based on different machine learning technology in Forever. And it's all personalization, learning new things in real time, very few examples, and then recommending those people that you want to share with. So I want to finish up by talking a little bit about how we think about research at Clarifai. So you can see we're very product focused, and we found that that's a certain type of person who wants to do research that is tied to solving a real-world problem as opposed to an open-ended problem. And so our decision to do research really comes from problems we think are going to make an awesome product and be able to come to market as soon as they're ready, as soon as they come out of research. Or they come from customers asking for something that is repetitive. We typically don't work with customers if it's only one customer asking for this thing. We want to see a common interest from multiple customers before we invest time and energy into it. And we structured the team a little bit interestingly. So data science and research are separate teams, and they actually sit kind of interweaved with each other. But the way we think about it is research is solving problems we don't have a solution for today. So all of you are research scientists in this room, and you guys are working on really cool open-ended problems. But when you're in academia, you usually have to deal with collecting data or downloading a pre-collected data set, which is time-consuming, and then you have to download a toolkit and get that up and running. So that all takes time away from actually solving interesting problems. So we factored that out at Clarifai. The research team just solves interesting problems. The data science team collects data from customers, from web crawls, and builds the models as well. So once the research team figures out a solution to a problem, they pass it on to the data science team, which injects it with data and iterates on parameters and all that kind of stuff to make it production quality before it goes out into production. So it's really fun to do research at Clarifai because you don't have much of the bottlenecks that you have at other places. And this is one of the common questions we get asked. What about data? How do you guys get data? So we actually have about 100 plus data sets now across all different verticals. So medical, I talked about, travel, social media, quality, stuff like that. A lot of data sets around faces. So it's really exciting because you can work on all these different problems and jump between them because a lot of them are very related. And in terms of quantity, we have over 1 billion images now labeled. So one of the things we take pride in is not having to label this stuff ourselves. So we can build automated systems to collect massive amounts. And all of the results you saw today were from those automated systems. And that means crawling the web a lot, but it also means being able to cope with noisy data. So we've developed algorithms that let you train these models in the presence of highly noisy data. We also have labeled video, so lots of labeled video. And these numbers don't include any public data sets that we can download. So it's all kind of unique to Clarifai. And this is a team between data science and research. It's composed of both kind of neural net backgrounds like myself and David Eigen and Nand Dalal down here, but also math and physics backgrounds and computer science masters. And we're looking to hire all of you. So you can apply at clarifai.com/jobs. And we look for interns as well. But one of the common questions, or a couple of them, and I just got asked one of these this week, can I work remotely? So we definitely hire full-time employees to come in and work at Clarifai, and we can work on any kind of visa that you might need, but that also is really difficult for students who are working at schools outside of the country. It's hard for them to get visas. It's just a long process, takes many months, either for internships or for full-time. So what we want to do is solve that problem. But also publishing, we get that question, and that's not necessarily our core focus. We want to build these solutions to real-world problems and build products around them, and so we haven't been focused on publishing. But we're really excited to announce something new today. So I'd like to introduce Clarifai Research Collaborations. So this is a new program we're starting up where you as a student can stay at school, at your university, wherever you are in the world, and work with us. And we're going to work on interesting problems that are not using public, academic data sets. You're going to be working with real-world data, working on real-world problems that end users will benefit from. So you'll have a big effect on them. And this is really exciting because you get to work with some of our research staff on some of our infrastructure as well, and get to learn from your peers in the program. So it's just starting off today, opening up applications for the program. We've done a similar thing in different disciplines around developers, and now we're bringing that to researchers. So you can apply at research@clarifai.com. To start, we're just going to ask you for a few simple pieces of information: your name, school, what year you're at in your program, the professor, what current focus you're doing in your research, and future interests, because what we want to collaborate on might not be your current focus. It might be something you're just really excited about, and maybe it's something you can't even do in academia, but you need some industry help. And so we can help you with that, and your resume, of course. So that's opened up now. And the goal of this program is to help you publish papers as well. So this is one of the reasons we're doing this program, is we want to get some publications out and collaborate with some of the great students out there. So this doesn't derail your PhD progress or your master's progress. You'll be publishing in this program and working on really cool projects.